Number 6, we're still talking about a deck of 52 cards, but now I'm only taking out one card. First, I want to know the probability of getting an ace or, so I shouldn't have written that yet, or a red card. So that would be the probability of getting an ace plus the probability of getting a red minus the probability of a red ace. I just realized I wrote the wrong symbol earlier in the first part. My apologies. That should have been the union symbol for ace or red. So of our 52 cards, 4 of them are aces. And you're only drawing one card, so you still have 52 cards to choose from, half of which are red. But then, of your 52 cards, there are some cards that are red aces. 2, in fact. There's the ace of hearts and the ace of diamonds. So you got to take those back out because you can't count them twice. So if I add those up, 4 plus 26 minus 2, I'm going to get 28 out of 52, which reduces to 7 out of 13, I believe. Yeah, 7 out of 13. And I'm showing my work, so even if I screwed that up, I still get partial credit. On the AP test, you still get full credit. Show work always. So we got our probability. So then I want to know, those events of being red and an ace, are they mutually exclusive? Mutually exclusive would be if you drew a Venn diagram, is this empty? So I guess I shouldn't put a 0. If it's 0, then it's mutually exclusive. If there's any other number in this space, they are not mutually exclusive. So that space is the intersect of those two events, and we just said that there are 2 cards in there. So because there's overlap, they are not mutually exclusive. My explanation could be that 2 red aces exist in the deck. Then I want to know if they are independent events. So I want to know, how does the probability of red, if I know I have an ace, compare to the probability of just a plain old red card in the first place? So the probability of a red card is half. We know half of the deck is made up of red cards. But if I take a card out of the deck and I tell you it's an ace, there are only 4 cards that I could have. Of those 4 cards, 2 of them are red. So given the condition that you know I'm holding an ace, you've got a 1 in 2 chance that it's red. These are the same, therefore they are independent events. So because these are equal, they are independent. You could have tested it the other direction. What's the probability that you have an ace given you know that it's red, and compare it to the probability of red? So this is another test that you could have done. So red cards are a quarter of our, what am I saying? Sorry, I screwed that up. That's my other test. Because you always just test this first event given the second, compare it to the first event. My apologies. So the probability of getting an ace, of our 52 cards, there are 4 aces, which reduces to 1 out of 13. But here, if I tell you, hey, I'm holding a red card, there are only 26 cards I could be holding. Of those 26 cards, there are 2 aces in there, because there's the ace of hearts and the ace of diamonds. So you could have tested it that way as well. You're still going to get that they are independent events. And then finally, I want the probability of a red face card. So I got 52 cards that I could be choosing, and I want it to be a jack, a queen, or a king, and it to be red. So there's the jack of hearts, there's the jack of diamonds, there's the queen of hearts, there's the queen of diamonds, there's the king of hearts, there's the king of diamonds. Those are all the face cards that are red. So there are 6 out of 52, which reduces or is approximately 0.11